Good day, grade 10s. How are you guys doing today? Welcome to a physics lesson. Today we're looking at kinetic energy. We should be able by the end of the lesson to define the term kinetic energy. Not kinetic energy 2. That was just a typo. It's called a typo, a typing error, right? In the previous lesson, if you guys remember, we looked at potential energy and the calculations that are involved when we're dealing with potential energy, the formula which we use when calculating potential energy, which in that case was mgh, mass multiplied by gravitational pull multiplied by height. That's the formula for PE. Then now for kinetic energy, we'll find that we're going to carry out calculations using the formula for KE. It's actually EK. It's actually EK. It's not KE. It's K. It's EK. Yeah, EK. Kinetic energy, half mv squared. So you'll find that whenever we talk about kinetic energy, it's always E with the subscript K. I don't know why I was writing it like this. Weird. Okay, so kinetic energy, energy possessed by moving bodies, right? This is energy possessed by moving bodies. Anything that moves has kinetic energy. This is a basic concept that we got from our earlier studies, earlier as in last year, grade 9, grade 8, we talked about kinetic energy. I'm sure even when you were in primary school, you were told certain things about kinetic energy. So what we're mostly concerned with now is the knowledge and the fact that anything that moves possesses kinetic energy, and how are we then able to calculate this kinetic energy? That's what we're mostly concerned with. So the formula for kinetic energy should read EK is equals to half mv squared, where m is representing the mass of a body in kilograms and v is representing the velocity of that particular moving body, and it's squared. Don't forget the squared part. Right, so if we look at right now, these objects are stationary, but they represent objects or things. I couldn't find a better word for the word objects, a better synonym. What is that? Synonym? I don't know. Right, for the word objects. So these are things which are usually moving. That's a roller coaster. I don't know if you have roller coasters here in Namibia. Do you guys have roller coasters? I know you have trains, but that's a Formula 1 car. Tuna. Remember when we say the Formula 1 car? That's a Formula 1 car, right? A Formula 1 car, it has a low base, but also if you see even the modern Formula 1 cars, they have these big white tires. That's for you, Tuna. That information is for you. You were asking about it. That's a Formula 1 car. They have big wide tires, and that gives them more stability. Okay? So, if we're
kinetic energy is the energy stored.
Sorry. So, if we're talking about kinetic energy, we're saying kinetic energy is stored in moving objects, right? There was volume on that one. Stationary objects have no kinetic energy. Basic stuff. Right, so the formula now, kinetic energy, would be EK equals to 0.5. 0.5 is half. Maria, you then asked to say, why is half v squared the same as v squared over 2? Then I said, if we were to say half Maria is the same as Maria over 2, is to say half of Maria is the same Maria divided by 2. Right? It's just a mathematical representation. We can either say half of Maria, or we can say Maria divided by 2. Right? Or we can say half of 100, or we can say 100 divided by 2. I hope you understand that. So this is half mv squared, the formula for kinetic energy, and the unit for kinetic energy would be in joules, right? So we would have kinetic energy there is in joules. We have mass would be in kgs. Let me try, and I'm just trying to lift the screen a bit here. pause it. Right, so we're still looking at the equation for kinetic energy. Half mass times velocity squared. Right. So when you have these objects and the object is moving, you have to know what the mass of the object is. Right. What is the mass of the object? What is the velocity of the object? So here we have a car, and it's going to have chemical energy changing into kinetic energy. Right. Let's look at this question that is here. So we have a car. Yes, that's a nice little car. It's a nice little car with a mass of 700 kgs, moving with a speed of 20 meters per second. Now you are supposed to calculate the kinetic energy of the car. That's a very simple question, yes? Because if you are given the formula, you know that kinetic energy is equal to half mass times velocity squared. So all you have to do is you have to square your velocity. This is your velocity, the 20 meters per second. This is the velocity. That is the mass. Half is always half, right? So you can then carry out your calculation. It's a very simple calculation. Let's see if we can be able to see what the response is. Or you can just calculate it yourself, right? Let's just pause the video for maybe a minute and just carry out the calculation so that you get to see if you got the correct answer. Okay, I hope you're able to carry out the calculation. So let's see if the answer that you got is the same as the answer that we'll get here. Okay, so that's the kinetic energy that you get. 140,000 joules. 140,000 joules. And then because the 140,000 is very big, what we can then do is we can then change it to kilojoules. And how would you change 140,000 joules to kilojoules? You change it by dividing by 1,000. Because if you have joules and you want to change them to kilo, remember kilo means 1,000. We also have a question here, cyclist and a bike have a total mass of that, speed of that, calculate the kinetic energy. You can also calculate the kinetic energy in this circumstance. So you will find that now on the PDF, the questions that I gave were slightly more challenging, as is life with science. We always give you in examples, we always give you these simple questions, but then when you get into the exam, you always find some ridiculous question waiting for you in there. Okay, so let's look at question number 4. A force of 6,000 newtons was applied on a stationary body. To solve them. By the way, just in case you were wondering if you got this calculation correct, that's how you were supposed to go about it, and that will be your answer. And I'll prefer all the answers that we give to be in kilojoules, right? I prefer them to be in kilojoules. The answer in kilojoules is also there, but the part that I'm recording won't allow it to show, right? So it will just be the 11.25, but you won't see it. But it's 11,250 divided by 1,000, divided by 1,000. Now let's look at this question. A force of 6,000 newtons was applied on a stationary body and caused it to move with the acceleration of 30 meters per second squared for 5 seconds. Find the car's kinetic energy. What I like about this question is that it has moved away just from giving you all the parts of the equation to say, here's your mass and here's your velocity. What has happened in this question is that you have been given acceleration. Okay? You've been given acceleration, and from that acceleration, you should now be able to deduce your velocity. Okay? So, first, also, you are given a force and not a mass. So, this question, for me, is a better question than the other ones that we just looked at, because those ones, of course, they'll make you happy. You answer them just like that in a jiffy, but they won't really challenge you that much. This one gives you the opportunity to convert your newtons to kilograms, right? You can convert your newtons to kilograms. You can then also say acceleration is equals to, remember what the formula for acceleration is? Final velocity minus initial velocity over time, right? Therefore, v minus u is equals to at. You get back to the point where v is equals to at plus u, acceleration times time plus initial velocity. And you substitute and you calculate and you do all the stuff that needs to be done, right? So because we did equations of motion, I assume, not even I assume, I know that you should be able to do this calculation. Then you come back for you to then find the mass of the vehicle depending on the acceleration at which it is moving at, and then you calculate, right? I'm not doing this one for you. That's why I already did it. I already did the calculation for you, right? So first and foremost is that we have acceleration, and we want to change that acceleration so that we can find it instead as a velocity, right? We want to find it instead as a velocity. Then we also want to find the mass, and we know that mass is equals to, force is equals to mass times acceleration. Remember, don't just change this 6,000 newtons and say 6,000 newtons is 600 kgs. Please don't do that, right? Don't do that. Just say we assume that the force of gravity is not the same. This is a force of 6,000 newtons based on this acceleration of 30 meters per second squared. So for you to find the mass of this car, you have to divide the force at which it is moving at with the acceleration of that particular vehicle. Is it a vehicle? No, just a body. I don't know. Yeah, it's a car. It's a car. Yes. That's how you find that the mass of the car is actually 200 kgs. So now, when you have found the mass and you have found the velocity of the car, you can then go back and calculate the kinetic energy of that vehicle, and you then say Ke half mv squared. You now have your m. You now have your v. Your v squared. Remember, it's v squared, and it gives you 2,250,000 joules, which is the same as, if we divide by 1,000, we just remove those ones, and it becomes 2,250 joules. Right? It becomes 2,250 kilojoules. Right? So it's a simple concept, as we're doing in both chemistry and physics. We find that our concepts are simple because now we don't have to spend so much time with a lot of hula baloo. All we have to do is calculate, and we calculate using laws of physics, right? Laws of chemistry. That's all we have to do. So thank you guys for watching the video. Number 1, number 2, 3 I did for you as well. So number 1, number 2, 5, and 6, we'll do those ones either in the lesson or I'll just give them to you as your assignment. So thank you very much guys for watching all the way through the video. See you